Hello everybody, this is Rob Swatsky from the York campus of Hack, and welcome back to my Biology 121 Anatomy and Physiology 1 course. This is podcast 2.3a, Chemical Reactions and Energy. As we are learning in Chapter 2, the structure and function of living things is based on chemistry, and it is through chemical reactions that all of life's metabolic activities are carried out. We know that atoms can react with each other to form chemical bonds by gaining, losing, or sharing their outermost valence electrons. Chemical reactions occur through the breaking of old bonds between atoms and the making of new bonds. Although chemical reactions are very diverse, they all share some common characteristics. The starting substances in a reaction are called reactants, and the ending substances are called products. In the chemical equation of the reaction for the formation of water, 2 molecules of hydrogen gas plus 1 molecule of oxygen gas forms 2 molecules of water. The 2 hydrogen gas molecules and the oxygen gas molecule are the reactants, and the 2 water molecules are the products. The arrow in the equation represents the direction that the reaction is moving in. The reactants are always written to the left of the arrow, and the products are always written to the right of the arrow. In any chemical reaction, the number of atoms of each element is the same before and after a reaction. In our example, the reactants contain a total of 4 hydrogen atoms in the 2 molecules of hydrogen gas and 2 oxygen atoms in the molecule of oxygen gas. The reaction ends with the products containing the same number and type of atoms, 4 hydrogen and 2 oxygen, distributed across 2 water molecules. Matter cannot be created nor destroyed, but it can be rearranged. This is known as the law of conservation of matter. Chemical reactions rearrange the atoms of the reactants into new combinations in the products, with the products now having different chemical structures and properties. In addition to rearranging atoms, chemical reactions also involve changes in energy. Energy is described as the ability to perform work. The 2 major types of energy are kinetic energy and potential energy. Kinetic energy is the energy of matter in motion. Potential energy is stored energy, or the energy matter has due to its position. Energy can be transformed or converted from one type to another, but it cannot be created or destroyed. This is called the law of conservation of energy. A stretched rubber band is an example of potential energy because it is storing energy in the form of tension. The more you stretch the rubber band, the more tension it will have, and the more potential energy it will store. As soon as the stretched rubber band is released, the potential energy is transformed into kinetic energy as the rubber band flies through the air. Another form of potential energy that relates to cellular activities is chemical energy, which is the energy stored within a molecule's chemical bonds. As an example, gasoline is a fuel made up of hydrocarbon molecules that consist of carbon and hydrogen atoms held together by covalent bonds. When gasoline is burned during combustion reactions in a car's engine, the potential energy within the bonds is converted to kinetic energy, which turns the wheels of the car. In the body, most of the chemical energy is stored within the covalent bonds of large macromolecules, such as carbohydrates, lipids, and proteins. When these molecules are broken down through digestion reactions, their potential energy is converted into kinetic energy that powers all of the body's chemical reactions. We can also describe chemical reactions based upon how the overall reaction transfers energy. An exergonic reaction releases more energy to the surrounding environment than it absorbs. Remember the prefix "ex" as in exit, where energy is exiting or leaving the reaction. Decomposition reactions that break down large molecules into small molecules during digestion are examples of exergonic reactions. In contrast, an endergonic reaction absorbs more energy from the surrounding environment than it releases. The prefix "end" refers to taking energy into the reaction. Synthesis reactions that build large molecules out of small molecules, as in protein synthesis, are examples of endergonic reactions. The body's chemical activities often display incredible efficiency when it comes to conserving energy. Many of the exergonic and endergonic reactions that are part of the body's metabolism are coupled together. When reactions are coupled, the energy released from an exergonic reaction is used to power a nearby endergonic reaction. For example, the energy released from the exergonic reactions of digestion can be used to power the endergonic reactions of protein synthesis. Thanks for watching, and please feel free to contact me by email at rjswatsk@hack.edu if you have any questions or comments about the course.